I'm really pleased to be able to be with you today, and thank you very much for the invitation. I've been working in British Columbia for over a decade. In fact, it's very nice to have my colleague Sonia Xai'xais on the call, and Sonia and I published our first paper, I think my first paper in BC in sea lice back in 2007 or 2008, and I've sort of had a happy time of working with sea lice, including in your own communities, or data from your communities since that time. So what I'd like to do today, I guess it's morning with you, it's 7 p.m. with me, but what I would like to do with you for the next half hour is just to give a little bit of an overview of some of the key kind of sea lice population dynamic findings that we've come across, or we've sort of developed in the last 5-10 years even, I suppose, both within BC and then also further afield. I'm also aware that you're going to get a little bit of input later in the session from Lice, who knows quite a bit about the local conditions. And indeed, Simon will be talking a bit about the sea lice issues in BC directly after me. So what I propose to do in this talk is to kind of set the scene a little bit more broadly, to talk about how sea lice monitoring has changed and what some of the key reasons for that are, the results, the approaches to sea lice control and on farms and the monitoring the wild populations. We'll start looking sort of at a global scale, and then we'll focus on the BC coast as a sort of unit, all of the different regions within the BC coast. Then I'll say a little bit about specifically the kind of wild and farmed components of those populations and what sea lice patterns have looked like on those, and what we can and what we can't say, and what we should be cautious about saying. And then I will finish with a few comments about the Kitasoo area in particular, but I'm not going to say too much about that because I think there'll be an opportunity as you get input from both Simon and from Lice on that, although I'm very willing and happy to take questions in that area if that's appropriate. So let's begin by just reminding ourselves that sea lice are a global issue. Essentially, almost everywhere where salmon farming exists, and indeed where wild salmon populations exist, so do their parasites. They're a natural parasite of salmon. But there are reasons why sea lice in particular have become important in the context of the presence of aquaculture. It's important that we know what it is that we measure when we're talking about sea lice, what are the stages that are relevant and important, how do different regions and jurisdictions interact and take action when different sea lice thresholds are reached. We won't really get into too much detail on how sea lice are controlled in salmon farms, but that is also important in terms of thinking about long-term sustainability, particularly with the issue of selective pressure for sea lice becoming resistant to certain chemical treatments, but also potentially other types of treatments. And we even have to just acknowledge that not all sea lice are the same. So we have, in fact, many species of sea lice, and it's important that we're just aware of those things. So let's just put a couple of those things in context, and then we'll get to BC more specifically. So as I say, anywhere where salmon aquaculture exists, sea lice have typically been a challenge. The only place where that's not the case is, in fact, in the southern part of Australia, there in Tasmania, where there are salmon farms, but there are no real sea lice parasites of note. There's also very little farming of salmon in Japan, although there is a natural sea lice called orientalis in wild salmon populations there. But in terms of the North Atlantic, both the east and west coasts of America and of Canada, important sea lice parasite is in fact something called Lepitheris salmonis. Sometimes you'll hear people talk about leps. So Lepitheris salmonis are the primary parasite in most of these farming communities. And they're also typically the parasite that, or the species of sea lice is in terms of controlling. There are, however, and the Lepidoptera salmonis is specific to salmonid populations. There is a more generalist parasite that will parasitize other species of fish, as I'm sure you're aware, and those fall under the broad category of Caligus. And in particular, you have Caligus clemensi and other Caligus species in British Columbia. In Scotland and Ireland, we have Caligus Xai'xais, as they do in Norway. And Caligus Xai'xais have also been an issue on the east coast of Canada, although primarily Lepidoptera salmonis are the parasite of concern there. And then finally, we have Caligus Xai'xais, which is, again, a generalist parasite. There were obviously no salmon, there were no Atlantic salmon in Chile when the aquaculture industry started there, but this generalist parasite has moved from some of the rockfish and other rock cod and other fish that were in that area, and have become a challenge for salmon aquaculture in Chile. So this is not a unique problem in any sense to British Columbia. It's something that's dealt with across the world, but it is important that we are just aware of the fact that there are differences. There are also differences in why we're interested in sea lice. There are some contexts, and we'll see in a moment. I'm speaking to you from Scotland, and certainly in the Scottish context historically, and also I worked for a long time in Atlantic Canada, and worked very closely with the salmon industry in New Brunswick and in Newfoundland. And in both those contexts, sea lice can often be a challenge from a farming perspective, just in terms of managing the numbers on your salmon farms, and potentially at some points even a welfare concern for the farm salmon. That's very much not the case typically in British Columbia, where the focus is much more on any impacts that there might be on wild populations. And it's very seldom that you're going to be treating on a farm for the sake of the farmed fish themselves. The level of parasites that typically occur in British Columbia are ones that, farm fish would deal with normally fairly readily. Anyway, that's just to remind us of the general background to sea lice. I think I mentioned a few of these things. The issue of the stage of sea lice is important. How often we manage to count sea lice numbers. Typically in a farming context, this will be done weekly or even more frequently than that. You may have heard that there are also things like automatic counting machines coming on board with kind of application of machine learning, where cameras can essentially automatically look around in pens and assess sea lice levels. So we're going to be able to understand a lot more about sea lice numbers in farms as we go forward with new technology. In terms of the wild populations, typically this will be assessed during the migration period. In the case, for example, of yourselves, typically anywhere between March or probably into April in most cases through until June or July of each year, as we shall see. The reporting requirements are also different across the world. In some cases, data is only sent to the regulator. It may be a surprise to you that your colleagues or your fellow Canadians on the east coast of Canada don't in fact have any visibility around sea lice, or have limited visibility around sea lice, because it isn't actually a regulatory requirement to report publicly there, although many companies do make their own counting data public, so that there's transparency there, which is great. There's also cases such as your own. Another example would be Ireland, and to some extent Scotland, where auditors are sent by the regulator to farms to cross-validate numbers, and that's something that happens, as you probably know, on farms in British Columbia. And then just to say something about threshold, because this is an important issue. One of the roles I play is I sit on the technical advisory group of the Aquaculture Stewardship Council. And one of the things they have to do in terms of setting farm standards is to think about how to set appropriate standards for certified fish across the globe. And one of the kind of thorny issues is that the level at which you're required to intervene in different jurisdictions differs. So as you may well know, it's in the case of British Columbia, during the sensitive or out-migrating period, it's 3 motile or 3 mobile lice per fish is the threshold. In Scotland, where I'm based at the moment, the regulations are 2 adult female sea lice, at which point you must actually count more frequently, but you don't have to take any intervention. And then 6 adult females is the point at which you must take some sort of intervention. Now, that's the regulatory framework. Most companies actually work to something called the good code of practice in Scotland, and the good code of practice has much lower levels of 0.5 during the sensitive period, and then 1 adult female during the rest of the year. So 1 adult female, we assume a sort of a 1 in 3 ratio of adult females to the overall motile population. That's kind of not that different from 3 mobiles. But the one that kind of stands out to us potentially as being quite different is Norway, where a very, very low level of 0.1 adult females has been set during the sensitive period, or 0.5 during the rest of the year. And we'll say something about that in a moment, but it's just important to be aware that some of these things are in the background when we have discussions. And it does sometimes make it difficult to compare like with like, apples with apples rather than apples with oranges. So I just very quickly went to the DFO website today and had a look at the overall sort of summary for the Central Coast region up till sort of September of last year. And, you know, we see that, we shall come back to this later, but in 2013, and in particular in 2015, which will be interesting when we reflect back on some of the stuff that Dick's just been telling us in terms of the blob and its potential impact. But we can see in both 13 and in 15, these light green lines here are exceeding the 3 motile threshold that we would like to always be below during the migration period. So there is some breach of that, but broadly speaking, in most of the other years, in fact, in all of the other years, the levels are below that. And in fact, throughout the year, they're mostly below that level. We contrast that with the last couple of years here in Scotland. One of the challenges with Scotland is that there is not the same level of transparency in data. This is something that's produced by an independent NGO called Finfish, which has taken some of the publicly available data. And what we need to note here is that these are not motile levels, these are adult females. So you could multiply these numbers by 2 or by 3 to get an equivalent number in terms of what you're looking at in British Columbia. Or if we take this very conservative level here during the migration, this little red line, which is sort of a half an adult female or 1 adult female in terms of the rest of the year, what you can see is that there are many, many farms that are exceeding that level within the Scottish context. This sort of absolute regulatory level of 6 here is not being exceeded during the migration period typically, although it is sometimes in the rest of the year. I guess my point in showing this was that in terms of the kind of global picture, the level of control that's typically found in a British Columbian farm would be significantly more effective than is the case, for example, in Scotland or in Ireland. Of course, there are always variations on that theme. But what about Norway? It's got this really high level of control. So, you know, what happens there? Oh, the truth is that Norwegian numbers are in fact lower than Scottish numbers, but there's just a little caveat that I'd like to point out to you. And this is a paper that literally just appeared, I think, last week or the turn of the year. Yeah, so in the last week in the Journal of Aquaculture that one of my postdocs, 2 of my postdocs, in fact, myself, put together. I'm not going to bore you with all the details, but what we tried to look at was we've seen some evidence that in Norway, when you have these very, very low levels that you have to control to, that there can be unintended consequences in terms of the impact on counts. So what I'm going to show you here is if we look at the proportion of adult females to the total motile population, what do these graphs look like? Well, on the bottom left-hand corner here, we see the story for British Columbia. One of the nice things about both British Columbia and Norway is that the transparency is much higher than many other countries. For example, I could not produce this graph for Scotland because only the adult female numbers are reported in Scotland, not the motile numbers in terms of the government regulatory framework. So what we see here is that as the number of motiles increases, not unexpectedly, the number of adult females increases. And in fact, there's a correlation coefficient, it's called, the level of association between those two things is very high, 0.9. And there is in fact around 0.43 adult females to every motile in the British Columbian data. Now, if we look at Norway, First of all, we don't see this very clear association. This association is not anywhere as clear. And the number of adult females to the number of motiles appears to be only about 20%, so almost half the proportion in BC. And as you can probably see from the little line here, remember that the level of adult females in Norway is 0.5. And there does seem to be a little bit of an invisible hand here holding that line down. It could, of course, be that in Norway, because they have to treat more rigorously, that this is a consequence of lots of treatment. And therefore, we're getting this kind of flatlining because farms are going in and treating at that significant threshold. But it doesn't really explain these proportional differences. And we then went and looked a little bit more closely at the Norwegian data. And what you find is, so what I've done here is I've binned all of the data into 0.1 groups. And when the adult female limit in Norway is 0.2, i.e. during the more severe regulatory framework, you see this really clear kind of drop off. We call it a cliff edge or an edge effect in the data. And similarly, when the threshold then relaxes to 0.5 adult females, again, you see this kind of cliff effect happening in the adult female. You don't see any similar effect happening in the motile population abundance levels. So clearly there's some problem here with an unintended kind of reporting issue happening. And the good news for you in BC, because we're not here in Norway to get on their case in that sense, but the nice thing to know about BC is that when you look at the data in BC using the same approach, despite the fact that you have this three total motile limit, which is just here, there's absolutely no evidence of any kind of staircase effect, any edge effect. So what it seems to imply is that when you have a level of threshold, a target that's achievable and approachable, there's much less of a tendency to skew the data in some ways. And therefore, we can really believe that a lot of the data that's collected both by companies and by DFO and reported by DFO in the case of BC is very solid and robust. And therefore, it's very useful to incorporate in some of the modeling that we do. Right. Two slides here very quickly from a presentation I made, I think, in 2019, just after the Korean Winter Olympics, if you remember, back in 2018. And what I did is I just sort of tried to do a little medal table of how different countries did in terms of their availability of data across the globe. And in the farm column, I sort of thought that Ireland was probably the bronze, and particularly the west coast of North America, i.e. BC, in the silver. Norway, I mean, it's got 1,000 sites, for example, as opposed to, under 100 in BC. So not surprising that they have a massive amount of data. So we have to probably give them that top place. But when it comes to actually understanding what's happening with wild salmon, even back in 2018, we had almost 250,000 wild salmon sample points. And the data I'm going to just share in a moment is almost up to 300,000 fish. So we've done an extensive amount of sampling of wild outmigrating salmon over the last 20 years in British Columbia, and probably understand that better than almost anywhere else in the world. So that's something to be proud of. And I know that many of you also been involved in that process, but it's also something that's a challenge in terms of how do we utilize that to understand better some of the challenges of managing sea lice in that context. Okay, so that's the kind of global context. What about this BC-wide data? Well, as I say, almost 300,000 fish in the data set that we're talking about today, running right back from 2001 till 2020. I also have some 21 and 22 data, but not from all of the regions. And we're in discussion about whether we should update these last 2 years of data into a paper that we're currently preparing for publication. This includes over 400 wild sampling locations right up and down the BC coast. And in addition to the data that's created, for example, by company-sponsored counting, we also have some specific projects, the BAMP project back in the 2010 to 2012 timeframe, data from NGOs such as the Salmon Coast, the Cedar Coast out on the west coast of Vancouver, and incorporating all of these different data sets into a single source that we can then use as a scientific tool and resource. And at the same time, we also have buy-in and involvement from the three major farming companies, and data from over 100 sites over those 20 years, covering, say, over 600 different production cycles. So a significant amount of data that lets us begin to look at some of the key interactions and issues that we see. I've just shown this quick map here, and hopefully you can see it. It's a little bit blurred out for me because of my toolbar, but hopefully you can see it on your screen. And what this is showing is, it's just giving you an idea of the extent of the collection of the data across the BC coast. So you can see all of the 7 main DFO zones, as they were called. Now, of course, zone 2.4 has been divided into 3 separate zones, but at that time they were using this kind of general grouping of 2.4 on the west coast of Vancouver Island. You see yourselves up there in the Central Coast in Kitasoo. And what you see is, if there is a data available from a farm, which there isn't every year, you'll see a little orange line. If there's data available from wild, you'll see a blue line. So you can see, for example, in Discovery, we've got much less wild data. In the early years, again, in Port Hardy area, not so much wild data. So you see a little bit about the extent of the data. You can actually see in the sort of little triangles and circles in every area the extent and the range of places where sampling takes place. You know, typically, for example, in the 2.4 area, on the west coast of Vancouver Island, most of the sampling will happen in the same inlets where there are salmon farms present, which makes sense. In fact, probably one of the most sort of broad set of areas are your own sampling points in Kitasoo. And then the one other thing that you see on this graph, I don't want to get into too much detail now, but remember I talked about the importance of both Lepidopterus salmonis and Caligus, primarily Caligus clemensi sea lice. What this graph shows is, essentially, if you're on that dotted line in the middle, the 0.5 line, then you've got an equal number of Leps and Caligus on your fish, whether those are farmed or wild fish, in the orange and blue respectively. And what you see is that in many cases, there are similar proportions, and sort of 70 to 80% of the lice that we find both on farms and on wild happen to be Lepidopterus salmonis. So they're skewed towards the right-hand side of each of the little boxes, including within the Kitasoo area, as you can see there. But there are other areas, for example, particularly Port Hardy is the most obvious, where despite the fact that the majority of lice on farm fish are still predominantly Lepidopterus salmonis, around 70%, 75%, you can see that for all the years for which we have wild data, i.e. since 2011 onwards, there's a predominance of Caligus species. So we're in the left-hand side of that graph. So the Caligus are more dominant than the Lepidopterus. Only 25% of lice are Lepidopterus. So these kind of background pieces of the jigsaw puzzle are really important to put in context some of the specific findings that we make along the way. If we don't understand these kind of broader trends and these broader structures, then it's sometimes difficult to interpret one-off data points or single years or single sites in that case. Now I have to watch my time because I've probably only got 10 more minutes. So let me just quickly swing through a few other things. I'm going to be coming back to talking about farm level summaries by zone and by quarter in a moment. So let me just skip past this slide. I don't think we need to focus too much on it, apart from perhaps to say that, just to remember, 2014 to 15 was the year that, one of the years that we just heard about in terms of this idea of a warming event and what we know as the blob. And we see in 2015, one of 2 very high years of sea lice in terms of farm levels. Some people say, well, let's explore the associations. And in some cases, it makes sense to look at associations. So this is something, sometimes you hear people talking about the abundance of lice on fish, which means the number of lice counted per fish. And sometimes you hear people talking about prevalence, i.e. what proportion of the fish had any lice on them. And if we zoom in to this, looking at pink, and we limit ourselves to about 50% prevalence or below, what we see is this almost perfect straight line over these 14 years of data, i.e. it doesn't really matter when you're talking about abundance levels that are quite low on wild fish with prevalences less than 50%. It doesn't matter whether you talk about prevalence or abundance. These are essentially one and the same thing at these low levels of presence of infestation. But that's not always something that you can, that worked because we're talking about a measure that we take and we just sort of relate it in two different ways. And then we see this association, which is kind of, it's almost a mathematical result of the two ways of doing the measurement. But you've almost certainly heard the phrase, you know, correlation is not causation. You know, so if I tell you, you know, do increased sales of ice cream cause the number of people who drown in London to increase? And I do a graph and I say, yeah, look, here's ice cream sales along the x-axis, and here's the number of people who drown on the y-axis. And I can do a little, you know, graph on here, and I get an almost perfect, I get an R squared of 0.99. And I say, yeah, it's very, and you say to me, wait a minute, that doesn't make sense. There's no link here. And in this particular case, you probably would postulate that it's got something to do with temperature, as we find it's also got something to do with temperature often in ecological settings. So the months that are warmer in the year, maybe that top point there is July or August in London, we're selling a lot more ice cream, but there's also a lot more people out swimming, exposing themselves to the danger of being drowned. So there's some underlying factor, in this case, the weather, that's driving both of these two things. So this kind of apparent correlation is not that one causes the other. Ice cream doesn't cause drowning, but they both are related to some underlying thing. And it's really important when we try and think about these correlative questions to be careful about what the causal linkages might be. I know Sonia's on the call, so I don't want to be overly negative about this, but Sonia with some of her colleagues did this very nice paper back in 2010 on the linkage between wild and farmed salmon. Basically, they looked at the number of lice in April on farms and tried to relate that to the level of prevalence on pink salmon in May, the following month. And they got this really nice link. And they were honest enough, it's a little dotted lines around it, which I quite like. I haven't noticed the dotted line before so much, but they had this figure of 0.98, which when you read it as a correlation figure, the highest you can get is 1. So it's almost perfect. And I've always been a little bit worried about this. And one of the problems with correlation is that if you have these sort of fairly high outlier points, as they're referred to, and in this particular case, the outliers in this graph happen to be 2002 and 2004, when there were very, very high levels of infestation, these 2 points that you can see here, 2002, 2004, when there were very high levels of infestation. So what I did is I took their same model and I looked at our more recent data, and I just compared from 2005 until 2020. And when I left 2005 in the data set, I did seem to sort of find an R squared, nothing like as good as their 0.99, but there was some sort of association. But when I removed 2005, basically this dropped to, I could only explain about 20% of the variation of the sort of April farm versus wild May data, and certainly nothing like that 0.99. And I did a similar thing recently for Cermak, for their farms and wild data in the Clayoquot Sound area. And yes, these two data points here, which were 2019 and 2018 and 2019 respectively, they sort of pull the values up here. But actually, if you ignore those and look at the rest of these points, you know, this is the third highest level or the fourth highest level on farms, but one of the lowest levels of mean abundance on wild fish. And here's quite a high level of, you know, almost 1.5 LEPs motiles per, or sorry, total sea lice actually per wild chum. And yet there was a very, very low level of sea lice. So this kind of very strict correlative association, I don't think actually holds across BC, and we have to be really cautious about how we interpret that. And we've tried to do some fancy stuff. I'm not going to bore you with the models. Yes, I do epidemiology. We haven't talked much about that, which is good because it can be a little bit tedious and mathematical. But in this particular paper that we did for the Mushlet Inlet, which is over on the west coast of Vancouver Island, as I'm sure you know, we looked at, again, the link between the wild on this axis and the farmed. Don't worry too much about what this xi of t means. This is just some estimation of how high the levels of lice were on the farmed fish. And yes, we saw this association, so that was significant. However, what we found was that as you increase the abundance of lice on your farm, that was not significantly associated with an increase in the observed level of prevalence on the wild. So last couple of slides, just to draw things to a close. I did say I'd come back and talk about farm level summaries across the whole of the BC coastal area, which I thought you might be interested in. And a couple of things jump out at us. Let's focus first on the years. And we see here 2015. So the kind of year of the blob, if you like, or the year after the blob, the year in which the blob seemed to have a major impact. And you'll see that all across the sort of intercoastal area, this was the highest year on record, particularly over Q1 and Q2 of 2015. Not so obvious, particularly in the lower part of Vancouver Island in the southwest. A little bit of evidence on the northern part of Vancouver Island, but not unique in that, because that's actually been increasing in terms of the prevalence levels in Q2 for the last 5 years. But 2015, a really clear, distinct event that's happened. Interestingly, here, if we look at the Kitasoo level, farms in particular, 3.5, which is the DFO's designation for your area, both 2013 and 2015 saw fairly high levels in Q2. That 2013 is not seen elsewhere on the coast, so we have to think about why that might be the case. The other thing I did, I just removed 3.1 because there's not so many fish there, but I took away this very high outlier here in Clayoquot, and I took away this high outlier of 2015 in Kitasoo, and you actually see that across the board, you know, around about 1.9 to 1, with the exceptions of the Broughton. 3.3 is the Broughton Archipelago. It's actually got about half the level of typical infestation that the rest of the regions have. If we take these two levels out, everywhere else across the BC coast has similar kinds of infestation in Q2 typically. And one of the really encouraging things I thought from this graph is that when you see a high level of infestation in Q1, that's often an indication that you need to take some immediate action. And there's an opportunity then to control things going into the outmigration period. And unfortunately, partly potentially because of environmental conditions here in 2015, that wasn't possible. But in many of the other years where you see these kind of these bolded elements in Q1, the Q2 levels fall down because what's happening is there's a much better and more rapid intervention at Q1 to make sure that things are are contained. So that's the sort of situation in Kitasoo in terms of farm data. Quite similar to most of the other regions across the coast, with the slight exception of a couple of years here, the blob being even higher than all of the other areas. Perhaps because you're further north. It'd be interesting to talk to Dick about that. It's almost like the further north you go to Port Hardy and then to up to the Central Coast, the impact is even stronger than it is elsewhere, but I wouldn't like to stretch that too far. But one last thing just to say before we finish off with a couple of thoughts about risk is, why is there so much focus on the Broughton? I think part of the answer, of course, is that historically it's in the area that's had the most fish in it. So it's had the most farms, it has the highest level of biomass, and therefore, if you think about the overall sort of sea lice numbers, then you might think, well, it's the biomass plus the levels that are kind of interest. So this is just a graph summarizing the kind of biomass, which shows, typically it's been similar through the years over most of the areas. Klemtu is, or is Central Coast is kind of hidden in here a little bit, but you can see, where you are in that group. And one thing that you can do is you could, instead of having a threshold that was based purely on 3 motiles, you could imagine some scenario where you multiplied the number of fish by that threshold and had sort of an overall sea lice load idea. And this is just sort of a thought experiment in terms of think about that. And what you find here is, remember in the Clayoquot Sound, there was this absolutely massive outbreak in 2018 for whatever reason, not explained, I don't think, by the blob. And that's the only year where you actually see the overall number of the overall sea lice load in Clayoquot exceeding the threshold you might set. Here we have something similar for Broughton, again, well below the threshold that you might expect. Some of the smaller production areas, so yourselves, and then Port Hardy, you get lower levels of threshold because you've got fewer fish. But again, the typical number of lice has been lower. Remember, we saw that 2013 and 2015 spike happening within Kitasoo. So last couple of slides, what about risk? It may well be that Simon's going to talk a little bit about risk because he and a colleague, Brent Hargreaves, pulled together a sort of a nice metric of risk over a decade ago. If Simon's talking about that, that's fine. I don't want to steal his thunder and certainly won't talk about that. But an alternative that was sort of proposed around the same time was from the Pacific Salmon Forum, where they proposed that any wild fish that were less than half a gram, or the number of wild fish that were less than half a gram, which had more than one motile lice, should never be above 3%. So here's a 3% line here, and here's the number of proportion of fish that met that criteria. Back in 2004, we actually did have a breach of that. That was a very significant year of infestation. This is in the Broughton. This is us showing it for the whole BC coast. But actually using BC Pacific Salmon Forum's rules, we ended up with hardly any fish, because basically the number of fish that will have more than one motile louse and are less than half a gram is quite small. So we slightly modified this threshold and said, what about if we look at fish up to and including 1 gram, so slightly larger fish, which should be more resilient, but let's just be conservative. And let's say that they don't just have to have a motile louse, but they could have any louse all the way from a copepoded up. And as long as they've got 2 or more of those, then we'll say that's at risk. And we did this similar kind of assessment at the 3% line. And yes, indeed, here's the year of the top, 2015, where for pink salmon, there was sort of we went up to almost to 12% of fish had 2 or more of any stage of sea louse. But over most of the rest of the years, this risk threshold has been it's been kept even within this very conservative assumption about bigger fish and any stage of louse, i.e. even the very smallest louse. This threshold is very seldom risk. One last thing to say about risk, and this is just to finish off because many of you have probably seen this picture or one very similar to it. And my problem with this picture is not that these fish like this don't exist. My problem is that having a discussion around risk based on a picture like this isn't really a very fair representation of what we typically find. So what I did is, one of the slight problems we have with some of the more recent data is that we can't necessarily go down to the adult female level. We often only know the number of motiles, but between 2004 and 2012, I had almost 200,000 fish that I could distinguish the lice, or the lice were already distinguished right down to the level of adult females. And what I found was that 125 of those actually had 3 or more adult females. There's only 125 fish that looked like this fish here out of almost 200,000. But remember that 2004 was this very high infestation year. So let's take 2004 out of the equation. If we look at all of the other years, i.e. the other 11 years, only 6 fish had 3 or more adult female lice on them. So that's 6 fish out of 160,000 fish. That's less than 1 in 25,000. So to have a discussion about risk that's based on a picture of sea lice like this, I'm not saying that we shouldn't be really concerned about lice. That's something we should definitely keep a focus on. I'm not saying that this kind of scenario never exists. What I'm saying is this is the atypical scenario, and that what we should be having our discussion around is the realistic risks that exist and trying to mitigate those and manage those on farms, and then monitor them and make sure that those are having the desired effect in wild populations. So thank you very much for your time. I hope that was set up some context, and I'll be very happy to take a couple of questions if we have a few minutes. Thank you.